Welcome to Flawless Learning. In this episode, we'll explore data types and measurement scales. So, basically, there are two types of data. One is qualitative and another one is quantitative. Okay. Now, why understanding data types is crucial? First is understanding data types helps in choosing the right statistical tools and machine learning models. Now, feeding the wrong data type into a model is like trying to measure weight with a thermometer. It won't work, right? So, there's purpose of understanding the data types is ensure correct data preprocessing. It impacts model performance. It determines the best visualization technique. Suppose an example that using numerical data in a classification model can lead to poor accuracy. As that I said that if we measure weight with a thermometer, it won't work because thermometer is not a measuring kit for weight, right? So now the next slide is two main types of data. It's qualitative and quantitative. Okay, so there's a basically a difference between qualitative and quantitative data. Now, what is the key characteristic of these two data? Basically, qualitative data groups things into categories. Like if you group our human into two categories like male and female, and quantitative data expresses quantities. It's represent measurable values, right? Now, in qualitative data, that is categorical, there's no numerical meaning because if male and female, there is no numerical meaning, right? But in quantitative data, suppose you have that represent that measurable value like weight. So it's numeric. So it's had some magnitude and numerical meaning. For example, that qualitative data is categorical like gender, blood type. For gender it's male, female, then blood type it's A positive, B positive, O positive, then AB, this kind of thing. And for quantitative data, there's an example like age, height, income. This all are represent numeric value, right? So data comes into two broad categories. Now, four types of measurement scale. So let's talk about the measurement scale. Okay, so there are four types of measurement scales. What is the definition of measurement scale? So measurement scales define how data values can be compared and manipulated. Okay, so what's the purpose of measurement scales basically? So it think of measurement scales as a ladder. Each step adds more power and meaning to numbers. Okay, so, first purpose is helps in choosing the right statistical method. Now, second is defines meaningful operation like addition, division, this kind of thing. Now, there are four levels. Okay. Now, from least to more powerful. First is nominal data, which is labels only. Then ordinal data, that ordered categories. Then interval data, which is equal difference but no true zero. And then ratio, which is equal difference. There is exists true zero. Okay. So let's talk about one by one. First is nominal scale, which is levels only. So what is the definition? So data that represent categories without any specific order. Okay. So let's take an example like nominal data is like the names of your friends. It's just a label, not a ranking, right? Now purpose. So used for classification but cannot be ranked or measured. Okay. Now characteristic, they are categories only. There are no numerical meaning and there is no fixed order. Okay. So for example, suppose eye color. So a different human body is a different eye color like brown, blue or green, this kind of thing. So you can't rank this eye color that brown is very good, then therefore blue, then green, this kind of. You can't rank the eye color, right? And same for blood type also, that A, B, A, B, O. You can't say that A positive is a very good blood, then B, then AB. There's no numerical meaning. Okay, there is no fixed order. So that's the new nominal scale. Now coming to ordinal scale. So there's order matters but no fixed difference. Okay, so what is the difference between Ordinal and nominal. Basically in nominal there's no order, but in ordinal there is order. Okay, so definition: data that has a meaningful order but the difference between values is not fixed. That is the ordinal scale definition. Now what is the purpose? So basically ordinal data gives us ranking, but we can't measure the gap between labels exactly. Okay, so it's used for ranking but does not support precise calculation. Now characteristics, so it's a order categories. Now no precise numerical differences. Why I say this no precise numerical differentiation? Let's talking about the one example like movie rating. So 5 star versus 2 star. There is no education level. There's high school, there's bachelor, there's master, there's PhD, this kind of thing. Now you can't exact calculate that 5 star is how many and 2 star is how many. Like so basically, or you can't level that education level like high school, or so you can't measure the gap, right? So that's about the ordinal scale. But that there's a order, right? Because first is first 1 star, then 2 star, then 3 star, this kind of thing. Okay, now interval scale. So interval scale is ordered and equal differences but no true zero. Okay, so that's the most important like point, that no true zero, because there's difference between ratio and interval scale is exactly that in interval scale there is no true zero and in ratio scale there is true zero. Okay, so definition: data with order value and equal differences but no absolute zero. So purpose: allow meaningful comparison but cannot express ratio. Like 20 degrees Celsius is not twice as hot as 10 degrees, this kind of, right? Now characteristic is order with equal differences, no true zero point, and can perform addition and subtraction. So what is the example? Like temperature, 10 degree, 20 degrees Celsius and 30 degree, this kind of thing, right? So basically with interval data we can measurement differences but we can't say one value is twice another, this. Okay, now IQ score is also example of interval scale. Now next is ratio scale, the king of data. So definition: data with ordered value, equal differences and a true zero. Okay, so now you understand that what is the difference between ratio and interval, right? Now purpose: so most powerful scale, allow all mathematical operation. Then characteristics: so ordered and equal differences, has a true zero like absolute absence, right? And can perform all arithmetic operation. Now example: height 160 centimeter versus 180 centimeter. You can difference. Okay, so basically here you can say that okay, it's a gold standard. So when zero means nothing, if any measurement is zero, so that's mean nothing. Okay, so calculation make complete sense. Like one person's height is 160 centimeter, one person's height is 180 centimeter. So now you can say that yes, the second person is 20 centimeter more tall than the first person, right? So then income is 50k, 100 ka, this kind of, like twice as much. That the person's income is 40k and another person's income is 100k. Now you can say yes, the second person's income is twice as the first person. Okay, so that's the ratio scale. So basically ratios data is the gold standard. Okay, now why data types matter in machine learning? Now, what is the key takeaways? So, first of all, is categorical data is used in classification model, decision tree, naive bias, this kind of thing. So, when you build a model or when you are choosing a data set or the feature or the characteristic of the data, you have to be very clear about the data, that the data is categorical data or the data is numerical data, because it's all depend on the data types. In classification model we use that categorical data, in regression model we use that numerical data, this kind of thing. Okay, so numerical data works best in regression model like linear regression, neural networks, because suppose in machine learning model there is, in roadmap I already said you that machine learning has the two different, like supervised learning and unsupervised learning. In supervised learning there is also regression and classification. and regression is like that salary measurement, this kind of thing. Okay, predicting the salary, predicting the temperature, this kind of thing. So all about the numerical value. So you have to very clear about that what is that, what kind of data is numeric and what kind of data is categorical. Okay. Now, using the wrong data type can lead to errors and poor model performance, because if suppose in classification model you used a numerical data, so that doesn't work. It can lead to errors and poor model performances. When you're checking the accuracy of the model, you can't go that kind of satisfactory result, right? Now suppose example, so if you mistakenly treat zip codes as numerical value, your model may make wrong predictions. Okay, so choosing the right data type is like choosing the real fuel of a car. Make the wrong choice and your model won't go anywhere. Okay, now there's a quick quiz for you, right? So can you guess the data type? First is, what type of data is customer satisfaction, like bad, neutral, good? I know you can answer it. Now second is temperature is Fahrenheit and interval, temperature in Fahrenheit and interval or ratio scale. And third is, what measurement scale is monthly salaries in dollar? Okay, so that's quick quiz for you. Drop your answer in the comments below. Let's see how many of you get them right. Now, what's next, right? So basically, data types affect every stage of data science. Choosing the right scale is critical for accurate insight. And so in this, now we have mastered data types. It's time to explore descriptive analysis. Okay. So that's all for today.